24 hours in a day, and I get to do math, hey hooray. Y equals mx plus b with Mr. Ng, we're making history. Pythagoras, Euclid, and Gauss learn the math and you'll become the boss.
Hey guys, let's go over the 16.5 Integrated Math 3 Module 3 test on polynomial equations. This is version B. Number 1, if x minus 6 is a factor, I wanted to note that when you know that it's a factor, its remainder is 0. Find the remaining factors of the polynomial. So I'm just going to use synthetic because it's fast. I'm going to use the coefficients 1, 7, negative 38, negative 240. Bring it down, multiply, add. I'm going to get my calculator out. 13 times 6 gives me 78. That will give me a positive 40, 240, and that'll be 0. So this means you have x minus 6, x squared plus 13x plus 40. The reason why we do synthetic is that we can get it to quadratic, and it's something we know how to do, and I can probably just factor from here. Two numbers that multiply to be 40. I'm thinking 8 and 5. Okay, so is x plus 8 a factor? It is. And is x minus? No, it's not, because that one says a plus. Okay, let's go over this problem here. Question number 2, how many imaginary zeros does the equation have? X cubed plus x, remember imaginary will not touch the x-axis right there. So you have x cubed plus x. It's a third-degree polynomial. I factored out an x, and I'm seeing if I can solve by factoring. I set that equal to 0. I set this one equal to 0. Subtract 1. That's a negative 1. To get rid of the power to it, take the square root. You need a plus or minus. So this represents 2 imaginaries and 1 real. So the answer would be C. Now, to give yourself a hint, you could substitute in negative x and then count the number of sign changes. There are no sign changes, so there is 0 negative zeros. You could do the same thing for the positives over here. I kind of just did third-degree polynomial. If you do the number of sign changes for the positive, there are no sign changes, so there is no positive zeros. So I guess in this case, your extra 0 is just the number 0. Question number 3, let's go over the graphing calculator problem. All right, for question number 3, let's go ahead and put that into Desmos. X cubed minus 3x squared minus 0.0014x plus 1. And we are asked to figure out how to solve this. Well, the solving just means where it crosses the x-axis. So negative 5.32, 0.652 or 6.53, and 2.88. That is choice A. Question number 3 is A. Number 4, find all of the factors. So 4 terms. I'm going to factor by grouping. Remember to put it in like Z. There's no greatest common factor. X squared, X, 25, and negative 4. I can just set each of these equal to 0. There's one solution. I'm going to set this one equal to 0 and then solve by square root method by getting the c value to the other side. Don't forget, it's going to be plus or minus square root of -1 times square root of 25, so that would be 5i. Okay, so that would be x equals 4 or x minus 4, and x squared plus 25. Question number 3. Which of the following expressions are examples of either the sum and difference of cubes? Mark all that are an example of the sum of cubes or the difference of cubes. Okay, so it's kind of like multiple choice. A couple things that you need to remember. You could just write out the formula. I'll write them out really quickly for you. The sum of cubes is just a plus b cubed, and this is where I'm going to write it out, is my SOAP. Okay, so, and then I'm going to highlight this symbol so you can see it. S stands for same, opposite of positive, which is negative, and AP, which is always positive. Okay, and that SOAP actually applies to the other one as well, so let's just fill that out. So AB, A squared, AB, B squared. Let's do that for this one over here. Now we're going to have a minus sign, so A minus B cubed equals, what's the same? A, same is minus. Opposite of minus is a plus, and then plus. Okay, so it's just a formula you have to memorize. But SOAP's actually going to be in here. Watch this. It doesn't tell us how to start, but I can just eliminate problems based off of SOAP. Okay, let's write out SOAP. Same, opposite, always positive. Okay? Look at this one. If this starts as a positive, then this one has to be a minus, but it's not, so we're not picking that one. Okay? Okay, so I have same, so positive, opposite, always positive. That one works. Okay, let's look at the next one. Same, opposite. Are these opposites? No, so wrong. D. Number 6, what are the possible positive real zeros? From here, I'm just going to count the sign changes. So this is a plus, so I have yes, no, yes, yes. There are 4 yeses. So we had our possible positive real zeros. There are 3, but then you're counting down to 0, counting by 2s. So that would be B and D. Alright, use synthetic substitution. So this basically says your x value is -5, and that -5 is here. So bring this one down, and then you're going to multiply. So that would be -5, and then you're going to add these 2 numbers. Same thing. -5 times 2, which is -10. And then we're going to add down here. Get different color. This will equal -12. So then -5 times -12. That can be a positive 60. And then we're going to add those, and you'll get 28. So f of -5 equals 28 is my answer. Number 8, find the solutions. I'm just going to put this into my x. So A, B, C. A is 1, C is 81, so A times C is 81. My B value is 18. do it by 2. 3 times 27. 5, 6, 7, 8, 9. So which of those pairs? Okay, so let me do the box. One x to the 4th goes here. 81 goes here. And 18x squared is split between these two, so that's why you should have an x squared there. Okay, now we're just going to take out the greatest common factor. X squared, 9, and 9. So I have x squared plus 9, x squared plus 9. Now you can write those as 2. And to solve just means set it equal to 0. You're just going to be left with x squared plus 9. Subtract. Take the square root. Remember, when you take the square root, you have plus or minus. This is the square root of -1 times square root of 9. So that'll be, square root of 9 is 3, and I. And you can note, because you're actually doing it twice, that these are double roots, or a multiplicity of 2. I spelled that wrong. That just means that you have 3i, 3i, negative 3i, and negative 3i. Question number 9, factor completely. You'll notice if you count 2 terms, this is not a difference of squares, this is a cubic, because I have the power of 3. So we want something that looks like this. You can put that into your calculator, the cube root of 64. You realize that it's the answer is 4, because 4 to the 3rd power is 64. So I'm going to put a 4 here. What am I going to put into this parentheses here? So you can just do cube root. And you'll get 3x. So I'm going to put a 3x. This is my A, this is my B. 3x times 3x times 3x equals 27x cubed, and 4 times 4 times 4 equals 64. I'm going to write out my formula for a plus b to the 3rd power. Oh, I'm going to write my acronym. Same, opposite, always positive. Let's see. I don't need that one over here. That was wrong. A squared, opposite, it's minus AB plus B squared. So A value is 3, goes here, there, and there. And then our B value is 4. So A is, pay attention, I like to write this in a parentheses, plus B, 4. My A value is 3x squared minus 3x. B value is 4 plus 4 squared. So I don't need those, so 3x plus 4. 3x squared is 9x squared minus 12x plus 16. You'll notice that second part is never factorable again. And question number 10, sketch the graph of a third degree polynomial with the functions x plus 2 squared and x minus 1. So I'm thinking about a basic graph. X to the third means like x to the first, so start down and up. Leading coefficient, I'm assuming is positive, so these arrows will stay right there. Let's talk about our multiplicity here. So x plus 2, and you'll get x equals negative 2. So this is my x-intercept, and the multiplicity there's 2. 2 means a bounce or a kiss, because it's an even multiplicity. This one, x minus 1, so x equals 1. And this one has a multiplicity of 1, which is a shoot through. The trick to find the, you don't have to have a multiply it all out, you can, but I have 2 times negative 1, so that'll be a negative 4. So I have a y-intercept of negative 4. Okay, so we said the basic graph, the arrows start down, ends up. We have one at negative 2. That's going to be a bounce. X equals 1. It's right here. We're going to go left to right. So yellow, we're going to bounce. And we're going to shoot through there. So my graph's going to look something like this. Okay? Hopefully that was helpful. See ya.
Do you want to learn to love math again? Go to Mr. Ng's website or to his YouTube channel. He will teach you to learn to love math again. Mr. Ng, the #1 math teacher in the whole world.